The Life and Discoveries of Albert A. Michelson. Measuring the Speed of Light. Welcome back to our channel. Today, we're exploring the life and groundbreaking work of Albert A. Michelson, a physicist renowned for his precise measurements of the speed of light and his innovative contributions to experimental physics. Michelson's experiments not only advanced our understanding of light, but also played a crucial role in shaping modern physics, including the development of the theory of relativity. So who was Albert Michelson, and what were his key contributions to science? Let's dive into his life, his discoveries, and the lasting impact of his work. Albert Abraham Michelson was born on December 19, 1852, in Strelno, Prussia, now Strzelno, Poland. At the age of 2, he emigrated with his family to the United States, settling in San Francisco. Growing up in a new country, Michelson exhibited exceptional intelligence and a strong interest in science from an early age. He attended the United States Naval Academy, where he graduated in 1873. His time at the academy sparked his fascination with physics and optics. After graduation, he continued his education at Columbia University, where he studied under the influential physicist John William Strutt, known as Lord Rayleigh. Michelson's early experiments focused on measuring the speed of light, a pursuit that had intrigued scientists for centuries. In 1877, while teaching at the Naval Academy, he conducted his first experiments using a modified version of Foucault's method for determining light speed. By 1881, Michelson had developed a more sophisticated apparatus that allowed him to measure the speed of light with unprecedented accuracy. He determined it to be approximately 299,853 kilometers per second, 186,329 miles per second, a value that was significantly more precise than previous measurements. One of Michelson's most significant contributions to experimental physics was the invention of the Michelson interferometer. This device splits a beam of light into two paths, allowing for precise measurements based on the interference patterns created when the beams are recombined. The interferometer works by sending light through a half-silvered mirror that splits it into two beams, traveling at right angles to one another. After reflecting off mirrors placed at the ends of each path, the beams return to the splitter and create an interference pattern, alternating light and dark bands that indicate differences in travel time between the two paths. This innovative instrument enabled Michelson to conduct highly accurate measurements not only of light speed, but also of other physical phenomena. It became a fundamental tool in both optics and metrology. In 1887, Michelson collaborated with chemist Edward W. Morley to conduct one of the most famous experiments in physics, the Michelson-Morley experiment. This experiment aimed to detect the presence of the luminiferous ether, a hypothetical medium through which light waves were thought to propagate. The experiment compared the speed of light in perpendicular directions to determine whether Earth's motion through this ether would produce measurable differences in light travel times. To their surprise, Michelson and Morley found no significant difference between the speeds of light in different directions, leading them to conclude that ether did not exist. This negative result was pivotal. It challenged existing theories about light propagation and laid groundwork for Albert Einstein's theory of relativity, which ultimately eliminated the need for an ether concept altogether. Michelson continued refining his measurements throughout his career. In 1926, he conducted a landmark experiment using a 22-mile baseline between Mount Wilson Observatory and Mount Baldy in California. This experiment yielded an even more accurate measurement for the speed of light, approximately 299,796 kilometers per second, 186,287 miles per second. In recognition of his groundbreaking work, Michelson became the first American to receive the Nobel Prize in Physics in 1907. His contributions significantly advanced our understanding of optics and solidified his place as one of history's great experimental physicists. Michelson was known for his meticulousness and dedication to scientific inquiry. He believed that experimentation should be guided by precision and rigor, qualities that defined his approach throughout his career. Beyond his scientific achievements, Michelson also had a lasting impact on education. He served as a professor at various institutions, including the University of Chicago, where he inspired generations of students with his passion for physics. Michelson's legacy extends beyond individual experiments. He is remembered as a pioneer who bridged classical physics with modern theories. His work laid essential groundwork for future developments in fields such as quantum mechanics and relativity. Today, Michelson's contributions continue to influence various scientific disciplines. The principles underlying his interferometer are utilized in advanced technologies such as laser interferometry, an essential technique used in gravitational wave detection. Moreover, Michelson's work on measuring light speed has implications for our understanding of fundamental constants in physics, helping refine measurements used across multiple scientific fields. In conclusion, Albert A. Michelson's contributions to experimental physics have fundamentally shaped our understanding of light and its properties. His pioneering work on measuring the speed of light not only advanced scientific knowledge, but also paved the way for revolutionary ideas in modern physics. Thank you for joining us today. If you enjoyed this video or have any thoughts, please comment below. Don't forget to leave a like and subscribe for more.